Yesterday we went over our triangle congruence, 5 different theorems we have and postulates to prove triangle congruence. Today we're entering into the world of CPCTC, which is your friend, but like any good mystery novel, it starts off kind of evil, and then you realize the beauty of it later on. So CPCTC stands for corresponding parts of congruent triangles are congruent. Our EQ today, you know two figures are congruent. What can you conclude about the corresponding sides and corresponding angles? We're going to try and use CPCTC to prove parts of triangles are congruent. So let's jump into it. You need to write that down, probably all of it. CPCTC is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. Get it tattooed on you. Okay. If it can be used as a justification and a proof after you have proven two triangles are congruent. Remember that side, 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 angle, 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 side, and hypotenuse leg use corresponding parts to prove triangles are congruent. So after you've done one of those 5 postulates, after you use one of those 5 postulates, you can then use CPCTC to prove that the corresponding parts themselves are congruent. Alright, so we'll come back to it if we need it, okay? Okay, check it out. Here's an example of how we would use this. It says A and B are on the edges of a ravine. Ooh, let's make it real life-ish. Exciting. What is A and B? Well, check it out. One angle pair is congruent because they are vertical angles. You guys now recognize, hopefully after doing this for a couple of weeks now, that this angle and this angle are going to be congruent with the vertical angles. Yeah? Okay. Right? And it says 2 pairs of sides are congruent. Now, it doesn't give me tick marks. Instead, it gives me the measurements. Is 10 equal to 10? Yeah. So I put my tick mark. Is 15 equal to 15? Okay, now use your noggins about what we did yesterday. No reflection property here, so try again. Okay, what would this be? What theorem? What theorem would I use? Side, angle, side. Side, angle, side. Okay, so once I've used side, angle, side, I can conclude using side, angle, side that the 2 triangles are congruent. Right? That's where we stopped yesterday. So now, what's the measure from A to B? Okay, 18 is the correct measurement. If you want to know why that is, it's because each of these side lengths in these 2 triangles and each of the angle measurements in the 2 triangles are congruent. Because corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. Okay. All right. Another example. Oh, a landscape architect. Yep. He sets up the triangle shown in the figure to find the distance JK across the pond. What is JK? Okay. Well, again, you aren't going to be given all the answers. So go through the problem. Go through the process. Determine if the 2 triangles are congruent, first of all. You see the vertical angles. The vertical angle is going to be congruent. Thank the Lord, that's the way He made it. Always they're going to be congruent. Is 30 feet equal to 30 feet? 19 feet equal to 19 feet? What theorem am I using here? Side, angle, side. Side, angle, side is true. Therefore, the 2 triangles are congruent. If the 2 triangles are congruent, the next logical step now is to say the corresponding parts of those 2 triangles are congruent. That means if this is 41, what is this? angle measurement right here was 39 degrees, what would this angle measurement down here be? 39 degrees. Okay? Yay! All right. That's all we got. Help me out here. Okay. You got to write this one down. Write this one down. I'm given that YW bisects XZ. I'm also given that XY is congruent to YZ. Write this one down. Douglas, write this one down. After you've written it down, you've drawn this picture, add to your diagram the information that you've been given. Draw. Right. Watch how I would do this proof. I'll go back to this drawing. Okay, check it out. Where do I start with any proof? Where would I start? Give them information. If YW bisects XZ does, what does that mean about these two angles? XYW and ZYW. They're congruent. Okay. That means that they are congruent. If XY is congruent to YZ, what's true about these sides? They're congruent as well. Okay, I've got side, angle. What am I going to look for here? Side. Which side is going to be congruent to itself? YW. Okay. YW. That side, angle, side on both triangles. Side, angle, side tells me that what? It means a triangle XYW is congruent to triangle ZYW. Okay? It says prove that XYW is congruent to ZYW. I'll be honest with you, your definition of angle bisector proves that's true. Okay? So really truthfully, we don't even need a triangle proof to do all that, but let's just pretend like I wanted to get angle X and angle Z for their congruent. Now that I've proven the two triangles are congruent, I use CPCTC. You can write it in abbreviated form. CPCTC to prove that corresponding parts of the congruent triangle are congruent. Okay? That is all I need. After I've gotten that part down, I can say anything I want. I can say XW is congruent to ZW. I could say angle X is congruent to angle Z. Any side or angle that's in those two triangles would have to be congruent to each other, as long as they're corresponding. Okay? You see how, y'all play Uno, right? Probably the best card to get in. Wild card. When the plus 4. Yeah, wild card, plus 4, where your person next to you has to draw 4, plus you get to pick a color, right? Yeah. I mean, I've been playing Uno a year or two. Y'all play that Uno, right? Correct? Draw 4, and it's got the little, all the colors. You're like, color's blue now, right? Think about this guy right here as your wild card. Okay? Because it does what? It changes. That's when everything changes, right? That's when all of a sudden, once you can sit there and lay this CPCTC on me, right? That means that I don't have to worry about any of the other, definitions and theorems, all that stuff. This is like your ultimate theorem. Okay. All right. Another one here. NO is parallel to MP. Parallel. Yeah, write this one down. And angle N is congruent to angle P. I'm going to walk you through this one. I'm going to introduce you a parallelogram. But there's some things that we should be able to see even without that. Write this down, please. Yes, sir. Ask the class. Okay, very well. All right. If NO is parallel to MP, and if angle N is is congruent to angle P, now check this out. I'll lay this on you. I've got parallel lines that are cut by another line. What does that mean about this angle and this angle? They're congruent. What theorem? Got it? What you got? Not given. Give you a hint. Are they inside or outside of the parallel lines? Inside. Are they on the same side or alternate sides of the same person? Alternate interior angle theorem helps me conclude those two angles are congruent, and these two angles are congruent. Now, that's great. That is wonderful. Can I now use my angle theorem? Do you have an angle theorem? Sure. Oh, you do? No, you don't. Okay. But there's one more piece of information that I do have already, just based on this drawing. What about NO? It's congruent to itself, correct? With a reflexive property. Now check it out. Angle, side, angle. Angle, side. Either one of them. Which one do you want to use? Angle, side, angle. Perfect. Angle, side, angle, angle, side, angle. Angle, side, angle tells me the triangle MON is congruent to, watch how I write this one, triangle OMP. Okay. What comes next? Don't tell me out. CPCTC, correct? CPCTC is your next logical step. So if that was our first step, here's our next one. These are my statements, and here is my justification. I'm not doing this probably the easiest way. This would be on the left side of the column. Justification would be on the right side of the column. Okay. CPCTC would prove that MN is congruent to OP. Okay. And we haven't learned this part. I said that I have to teach you. If you got two pairs of congruent segments in a parallelogram, you have two pairs of parallel lines in a parallelogram. Okay. That's coming next week. angle, angle, side. Good for them. Okay, but you see how your alternate interior angle theorems came into play here? Okay, CPCTC, they use this converse. Don't worry about that one, okay? They use the converse of the alternate interior angle theorem says that, but if my alternate interior angle are congruent, and the line must be parallel. Okay? All right, guys, you might have something like this. You don't have to write this down. Do not have to write this down. Do not have to write this down. If I'm given, check out, that here are my two plots. Here's the plots I've got to use. D, E, and F, G, H, and I. I got to prove that triangle DEF is congruent to triangle GHI. I should say angle DEF and angle GHI. Sorry. Step one. They've done all this for you. Plot your points. Okay? Plot your points. That should not be that hard, right? That's like easy. Hopefully you'll see these like easy problems, correct? Until you get to this step. Use your distance formula 3 different times to find the side lengths of each particular side of that triangle. Okay? So they just use the distance formula to find D to E, E to F, and G to H. I'm sorry, D to E, D to F, E to F, DE, DF, DF. Okay? And then they used it again to find G to I, G to H, H to I. Notice what's happening here. D to F and G to I. D to F, square root of 13. G to I, which is square root of 13. D to E, 2 times the square root of 5. G to H, 2 times the square root of 5. D to E, 2 roots of 5. G to H, 2 roots of 5. H to I, with the square root of 5. And E to F, with the square root of 5. Square root of 5, square root of 5. What do I have there? How many congruent sides do I have? 3. What theorem will I use? Side, side, side. Look, I'm tired of this. We got 3 sides congruent. Right? Angle, side, angle, right? We got 3 sides congruent. Okay. Why on earth would you use the distance formula 3 times, find 3 sides congruent, and then try to put an angle? Okay. All right, so now that I've got 3 sides congruent, I can use side, side, side to prove that the triangles are congruent. And if the triangles are congruent, CPCTC would tell me that the angles that correspond must be congruent as well. Okay? Like CPCTC or not? No. Okay. All the letters are confusing you.